Hello and welcome to my channel. In this video, I'm going to try to speed the game up a bit. I'm also going to fix that thing where the game, when it can't win, it will continue fighting instead of just playing any move. Okay? Now what I'm going to do is, I want to switch it to using Minimax again. And what I've done is offline, I've taken these benchmarks. So that's what it was doing, exactly these, and I'm going to try and improve something and then try it again to see how it gets on. So I'm going to concentrate on these four functions. Okay, I'm also going to change something that's not going to really speed it up, but I need to change it. I'm going to set this infinity to 200,000. Okay. I'm going to change some other functions. Now the first I'm going to look at is this one. And when you look at this, you can see it's a lot of pluses and minuses and equals. So I don't think anything could be improved in this. These are all fast operations. You've got things like find the logarithm or find the square root or find the modulus or filter or using filters or using regex. Them are slow, they're very slow operations. These are all fast. So it's going to be hard to improve the speed of these. Okay, so I'm going to leave these as this one's going to be left as it is. This one, in fact, I already done one improvement on it, and that was that. I'm going to leave this one as it is. It probably can be optimized. Oh yeah, I can do that. I can take this out, so I'm not going to bother. I can just do minus dir instead of times it by -1. But that shouldn't make too much difference. So I'll leave that. I'll leave that alone, but I'm not sure that's optimized. This one here. Now this is bad. I need to put that. I need to put equals there. So that's what I'm looking at for things like that. And then also it's looping. I just noticed this. If it's looking for a win, if it's looking for 4 in a line, imagine there's 4. Imagine it's looping looking for 4 in a line. When it gets to here, there's only 1 4 in the line left, possibly. And then when it gets to here, there's none left. So it doesn't need to check these two squares. So I can probably improve performance by 3% or 4% by setting this to something else. So what I need to do is I need to bring the line in. So I do that. And then I'm going to do oops. Minus line plus 1 plus 1. So that will save a bit of time. Instead of, if we're playing 4 in a line, it's going to stop at this square and then not check for 3. It's going to not check these 3 squares. Okay. So that will save a bit of time. I can't see anything else in here. These are all fast. Again, these are all fast operations. Evolve for win. Now I've got to change this. I'm going to change that to 100,000. Okay. And that's it for now. I'm going to do one more. I'm going to do another test of this to see how it's. See if there's any improvement. I didn't know it was my turn for a bit then. I was daydreaming, or even though it's got it there, that tells me. What is the last move I'm gonna make? Now it went there because it's still doing that thing, but I'm gonna fix that in a bit. So these are the new timings with them little things I've done. It's about a 3% saving, I think. Okay, can you see that's a bit of a saving? I'll just check this one. 7542. In fact, not all of them are faster. That one's, wait there, is that right? 881. Yeah, that one's slower. Yeah, what I'm talking about is the saving. I'm looking at the wrong one. That's the that's the, what's it name? This is the benchmark, so I call it bench. I always call it BE. Or should I have called it BM? Okay, so as you can see, that's the benchmark, and it's improved by a teeny bit across the board. Okay, so let's do some more. Let's do some more changes. I'm gonna do something here that's gonna actually make it slower, but I have to do this. Now that thing where it doesn't fight to the death is because if you look in Minimax, what I first did is when I was programming this, I quickly put this line in, and it worked. I thought it worked, so I just thought, okay, that's good. I had the theory how to do it, and then it worked, and I thought it's a simple thing to do. Okay, and then when I started doing it on alpha beta, it didn't work. So I had to go through the game and look at some flowcharts and look at this and look at that and work it out, all that again. And I was getting fed up, to be honest, but I did manage to work it out. And what I've noticed is, where do all these scores come from? Like, you know, in fact, this is all the things I worked out. Well, anyway, you could say, where did all these scores come from? Okay. And I noticed that the scores, they come from here. That generates the score. That generates the score. And nothing else generates the score. Like when you go here, where does this get the score from? It goes down one level in the recursive function, and then it gets generated by one of these. Okay. So then I realized that, because it was going to get quite complicated, because what I was thinking is I'd have to do the score based on the side. So for instance, if the score was like, you have to put it, like I thought to myself, I have to put an if statement in. If the score is if the score is more than 100, then do this. If it's less than 100, do that. And that would obviously slow this down. And then I realized, and then I thought about it more and more. And then I realized that this is the place where all the scores come from. Okay, so what I'm going to do, I'm going to put something in here. Just going to paste it in. And that's all it is. this one is going to be, imagine this was still 100. Obviously I've changed it. But in fact, just imagine this is 100,000. What we want is, for when it can't win, we want the ones that are lower down the chain to have a better score. For instance, if it's going to be a winning 7 moves and the ply is 7, we want that to be, we want it to be less, so that the losing side will pick it because it's less. Okay, and it's achieved instead of putting what happened before, which was a bad thing. I'll put it here, and it worked. So I don't know why it worked, but it just worked for that minimax. Right, that's the idea I had. You just take the score off, take the play off there, and that would work. But that's not the way to do it. So what I'll actually do is I'm going to delete this line here. What I should have done is I should have put it in here. But I also have to set this to more. I've also had to set that. I've also had to set that to higher to 200,000. So just, that's why this number's increased. So anyway, now this is that minus this game's ply times 100. And this is the beautiful part. This one is plus. Okay. So one of them is minus and the other one is plus. So I don't have to work out which side it is. I don't have to do anything else because it's all here. When that is minus, you plus it. When it's plus, you minus it, and that will get the effect of, when you're losing, it will make the artificial intelligence play the best move. Okay, so that should fix that problem. Now, if you look at these functions, they're all, this one, especially this one, is very expensive. Okay, it's not a looping and everything else. So I'm going to show you. First I'm going to do minimax, and then I'm going to do the other one. Okay, here it calls a val for win, and that's very expensive, and then it calls it again here. Okay, so what I'm going to do is I'm going to take this out of there. And I'm going to put it there. Now I'm lost. I've lost myself. Okay, let's see. Okay, yeah, that's it. I'm going to take this out from there and just put it here. And I'm going to push that up, and that's going to calculate out a very expensive operation once. And then when I come here, I'm just going to do return score. Okay, but remember, most of the times only one of these run. So for instance, if the score is more, if the score is not equal to 0, that's not equal to 0, it won't run this. And if that's, the depth is less than that, it won't run this. However, because that is such an expensive operation, there's times when it will do it twice, and because we've done this to it, even though it doesn't seem that it will do much of improvement because that is so expensive. It will make a difference. So that's one thing we've improved there. But we've also made it slower by adding some things in the valuation. But however, it should equal out. So another thing I've noticed is this line here. I'm not sure what this does. If move count equal to 0, do that, and that's an expensive operation. So what I'm going to do is I'm going to look and see what it does. If move count is equal to 0, that means it's coming here, and it's not a win. It's not a win, and the depth hasn't been reached, and there's no moves left. There's no moves. So that means the position is a draw. So I can do nothing here, I think. Let me think. It's just coming here. Best move equals -1. Right there. Let me just check something. Score. Yeah, score equals -infinity. And then the score is going to be equal to this at that stage. And then from here moving forward, it's always going to beat that -infinity. So therefore, I can do best move equals score, or I can do best move equals 0. And it doesn't really matter. Or if I look even more closely, I've got it says here. Right, let me think. If score is more than best score, problem is the score is -infinity, so it's never ever going to be best than the less score. So I can actually just blank this out, saying that this is a fast operation, so I'm not going to doing this won't save a lot of time. It won't have much effect because that's a fast operation. And let me just do a thing. Yeah, that's it. So now with the new improved game, it should be a bit faster. Let me have a quick check. Okay, I'm going to give it another test now. And let's see what scores we get. So now we're going to see whether it gives up quickly. This is the move this move will tell me whether that thing worked. And as you can see, it didn't. It knows that it can't win now. However, it still carried on fighting. And it fought again. And I think what it is on this move, I'm going to have 2 ways to win. So it's just going to give up. As you can see, I've got 2 ways to win. So you can see that that move gives the same value as these. And because it searches these moves first, it would always play that move. Okay, let's have a look at the timings for that. Oh, I've made a bit of a mess. I should have cleared it. But you can see that. Okay then. What it is, it's going to be these ones here. So the first one took 30.31. As you can see, there's a, how much improvement is there? If we look at the 939.078, we made something slower and we made some things faster, and still it's about a 40% improvement in speed. In fact, some of them are double the speed. Yep, and also it's fighting now. It's fighting to the last breath. Now, as you can see, I've changed the evaluation. The reason why that is, I might want to do some others. I might want to put some numbers in for doing certain other things. It's because at the moment, the evaluation function is just telling us whether we won or we lost or we drawed. I may have some values for putting a piece in a certain place that would. So what I can do is I could encourage the computer to put pieces in a certain place by giving bonuses. So I had to increase the overall numbers so that I can have a bonus for certain things and a bonus for when you've lost. Because I wouldn't want it, if it's lost, I'd like it to play the best move. I wouldn't like it to just put the piece in the middle of the board just because it's losing. Okay. Okay. The next stage of this is to do exactly the same for minimax. What I'm going to do is, for alpha beta, the code is pretty much the same. It's exactly the same. It's exactly the same thing I'm going to do with alpha beta. So what I'm going to do is I'm going to do it. I'm not going to do it on the video, but I'm going to do it. By the time I do the next video, it will already be done. So now I think I've maxed. I think I've made it faster. So bye till the next time. Thanks for watching my channel.